Okay, hang on a second. Get our screen. Okay, so continuing on. Student A is pushing 300 newtons east on a box. Student B is pushing 450 newtons west on the same box. It's on a frictionless surface. What is the net force on the box? So basically we've got an applied force of 300 newtons to the east and 450 newtons to the west. And so my net force is going to be 450 minus 300 is 150 newtons, and that's going to be to the west because there's more force to the west than to the east. So the student pushing to the west is going to win, I guess. I don't know. Okay. The Earth and the Moon both pull each other with mutual gravitation. The Earth is much bigger than the Moon, which pulls more. So as it turns out, they actually pull the same because of Newton's third law. The force of one object on another one equals the force of that object back, equal value, opposite direction. Okay, so it's the same force due to Newton's third law. Now, the difference comes from their mass and their acceleration. Remember, we talked about that with like the ball hitting the wall. In the case of the Earth and the Moon is much smaller, so it is kept in an orbit around the Earth. It can't escape because it's so much smaller. So the Moon pulls back on the Earth. It doesn't have as much effect because it has a smaller mass, but there is an effect, which is our tides, our ocean tides, come from the pull from the Moon. Okay. Okay, let's see. The force of friction is always same as or opposite the direction of motion of the object. It's always opposite. Friction is always working in the opposite direction of our motion. It's like it's working against motion, kind of. So, an object has a net force of 5 newtons up. What is something that you know about the object's motion? So I don't know the forces acting on this object exactly, but I know that I've got a larger force in the upward direction because that's where my net force is, and so I know my object has to be accelerating upwards because net force and acceleration go in the same direction because they're linked through Newton's second law. Sketch free body diagrams that could represent the following scenarios. At rest on a table, so this one we've drawn a whole bunch of times. We've got force of gravity, we've got normal force, they're equal value, opposite direction, boom. Moving at a constant velocity to the right, so again we have our vertical forces are balanced. And then if we're at a constant velocity, we got to have balanced forces to the right and to the left. So maybe that looks something like that. Moving to the left and speeding up. So here, hang on, my dogs are coming in. I'm going to have a larger force to the left than to the right if I'm speeding up in this direction, okay? And then moving to the right and slowing down. So now I've got my forces. I'm moving to the right, so I'm moving this way, but I'm slowing down, so I've got more friction to the left. Maybe I'm on a really rough surface, and so eventually I'm going to slow down to a stop, okay? Okay, this object experienced a net force of 20 newtons and an acceleration of 4 meters per second. So we're going to use that information to go back and figure out some other stuff. Okay, what is the applied force? Okay, so it gives me that there's a friction force. It tells me my net force is 20 newtons. So that means my applied minus friction has to be 20 newtons. Applied minus 12 equals 20 newtons. I'll have to go soon. Applied force is 32 newtons. I'm just solving that for applied force. I add 12 to both sides. Okay, so 32 newtons. So 32 newtons over here, 12 newtons over here. What's the mass of the object? Okay, so I'm given acceleration, and I know F net equals mass times acceleration. I know F net is 20. I know acceleration is 4, and then I don't know mass, but I can solve this. I can divide both sides by 4, and I'm going to get that the mass is 5 kilograms. What's the weight of the object? Fg equals m times g equals 5 kilograms, because I just got that, times 9.8. That's roughly 50 newtons, because I'm just rounding that to 10. Hey, Ollie, stop. And then what's the normal force? My normal force is going to be the same as my force of gravity, or my weight, because they're balancing each other here. Okay. Alright, and then last one on this page. A bowling ball with a mass of 10 kilograms and a golf ball with a mass of 0.5 are hit with the same force. Which object will have the larger acceleration value and why? Okay, so they're both hit with the same F net value. Hang on a second. I gotta stop this dog from barking. Okay, I'll continue in the next video.